Alright, so the other day we introduced polynomial functions in general. Today we're going to talk more specifically about quadratic equations, and we'll touch on inequalities. So you may remember from algebra, if you have something simple like this, if you have a quadratic that looks like this, 5x plus 6, and when you're solving it you set it equal to 0. You want to find out where the y values are 0. Well, these are the x values that make that happen. If you can factor it nicely, you go ahead and do so. And you set each of these equal to 0. Oh, I'm sorry, plus, that's a plus 3 equals 0. And you solve for x, you're going to get x equals negative 2, and you're going to get x equals negative 3. Which means that that parabola, wherever it is, has a negative 2 and a negative 3 root, and it's going to look something like that, give or take. Okay? Alright, fine. What if it doesn't factor nicely, though? Let me make this smaller here. Move that up. Alright, well, what if we look at this problem right here? Let's try to factor this one. You should always take a common factor out first if you can. So, taking out a... Oops, sorry. If we could take out a 2, and if we did that, we'd have x squared minus 4x minus 8. And if you want, we can get rid of that 2. And then we're left, and 0 over anything is still 0. So we're left with a nice simple trinomial. It looks like that. Let's try to factor it. We need an x and we need an x, and we have to think of two numbers that multiply to be negative 8, but add up to be a negative 4. Now let's see, what do we got? We have a negative 8 times 1. We have an 8 times a negative 1, we have a 4 times a negative 2, or we can have a negative 4 times a positive 2. And in all honesty, those are all our choices for negative 8, and none of these will add up to be negative 4, so this doesn't factor nicely. What do we do? Well, that's when we go to either completing the square or quadratic formula. Just get rid of this. Whoops, get rid. There we go. Excuse me. Alright, so here we go. You can solve, or me, or anyone, can solve an equation, a quadratic equation, by either completing the square or quadratic formula. Okay, and that's what we're going to do. We'll talk about the quadratic formula second. I want to first address number 1, the completing the square, because this is what most people forget. Okay, it's imperative that we revisit this because we're going to start talking about any degree polynomial and how do we factor them all down to their roots. This is essential in that process. Alright, so here we go. We have this problem, and I'm going to do the same thing we just did up here. I'm going to take the common factor of a 2 out because we might as well make our numbers smaller. You'll get the same value, but you might as well keep the number smaller. So if I divide both sides, let me change the color here. If we divide both sides by 2, like we did up there, we're going to get this, x squared minus 4x minus 8 equals 0. Alright, now the first thing you want to do is, we're completing the square. So what variable is squared? We have an x squared. So anything with an x, we're going to keep on one side. This has no x, so move it over. So that gives us this, x squared minus 4x equals a positive 8. Okay, we move the constant over to the other side. What's next? Well, you may remember, we are going to take this. This is the a coefficient, the b coefficient, and the c coefficient. We're going to take the b coefficient, and we're going to do this. We are going to take half of b, then square it. Once you square it, add that value to both sides. Add value to both sides. Alright, a little sloppy there, but anywho. Alright, let's do that. Let's take half of b. Half of b, well, b is negative 4, right? So what is 1/2 of negative 4? It looks to me like that'll be a negative 2. Okay, we take negative 2 and then we square it. So let's square negative 2. Negative 2 times negative 2 is a positive 4. That's the value we add to both sides. Let's add it here, and let's add it here. Great. And what that does for us, well, this side is easy. That one is going to combine my like terms and we get 12. Now, we're guaranteed that this is going to be a perfect square binomial. Binomial just means it has two terms. And, well, let's think about this. Let's factor this out nicely. That's going to give us an x minus a 2 times an x minus a 2. Okay. Here's a little shortcut. We're going to be doing this so often that what you want to do is when you're looking right here at the b coefficient, whenever you take half of b, right, what did we do? We took half of b and we got negative 2. Negative 2 is always, that's the value that goes in there. Whatever half of b is going to be the value with the x inside that binomial. Okay? We'll do a few more and you'll see that pattern. What do we do now? Let's change it to purple. Well, now we're trying to solve for x. We got to get that x by itself. However, it's being squared. So how do you get rid of a square? You square root it. You square root both sides. And when you square a square root, it frees up what's inside. We've talked about that before. Over here, most common mistake, people forget the plus or minus. We've talked about that also extensively. I'm not going to revisit it right now. If you have any questions, please ask tomorrow in class. We'll go over it again. Our job is to solve for x. Let's get x by itself. X equals 2 plus or minus the square root of 12. You can simplify the square root of 12, but it's not necessary. It's still the same value. And this is how you get your two roots, your two x values. You have x equals 2 plus radical 12, whatever that decimal is. And you have x equals 2 minus radical 12, whatever that decimal is. All right, let's try a little more challenging one now. Let's solve this quadratic by completing the square. Well, the first thing you need is this a coefficient right here has to be a 1. That has to be 1x squared. The problem we just did before, that was a 1x squared when we were working, not a problem. Well, if it's not, here's how you get rid of it. If you want a 1, just divide by whatever you need to. All right, I see I have a 2 there, so let me divide by a 2. This way I can get x squared. Okay, and then whatever we're left with is what we're left with. Okay? Now let's continue like we did. Let's move the constant over. And we will have a negative 2 on the other side. And now let's do that little math there of we're going to take half of the b coefficient, which in this case is negative 3/2. And then we're going to take that answer and square it. Well, don't forget when you're multiplying fractions, you multiply the top numbers here. So that was a negative 3 and 1. And then down here we got a 2 times a 2. Okay, so half of b, since we're at it, half of b goes there, right? That's a negative 3/4. And after we square it, that's a positive 9 and a 16. Don't forget you square the top and you square the bottom. All right, so now we have a positive 9/16. That's what we add to both sides. Don't forget, when you're adding fractions, you need a common denominator. So what is that? Negative 2. Well, how about a negative 32/16? That's negative 2. Now we have a common denominator. That's a 9. Add this up, you get negative 23/16. So this equals negative 23/16. Square root. When you square root a square or square a square root, either way, cancels each other out. And we have this, and like I said before, don't forget plus or minus. 23. Ooh, look what we got. We have ourselves an imaginary number. So whenever you get a negative right there underneath the radical, that is the same as I. So let's take that out and call it I. So that's a plus or a minus. Radical 23 over radical 16. I just want to remind you, how do you handle fractions under the radical? Okay, it's the same as taking the radical of both. And if you take out that negative radical 1, you have an I. X minus 3/4 equals plus or minus the square root of 23. What is the square root of 16? 4. Over here, let's just finish her up. I'm going to add 3/4 over here and add 3/4 over here. And that's going to give us x equals 3/4 plus or minus radical 23/4 I. And we have two complex roots. but more specifically, two complex roots that are imaginary roots. Now here's the quadratic formula. You should know this by now. If not, you got to get to know it, okay? What do the a, b's, and c's represent? Well, a x squared plus bx plus c equals 0. It's the coefficients. Plug them into there, and you get your two roots. Okay, so let's pull up that problem we just were working on. That was, let's see here. Let me make this smaller, red, and whoops. Okay, so we had 2x squared minus 3x plus 4 equals 0. All right, so here's our c, here's our b, and here's our a. And we get x equals negative b, negative 3 is positive. Plus or minus the square root of b squared, negative 3 times negative 3 is 9. Minus 4 times a times c. All over 2a, 2 times 2 is a 4. X equals 3 plus or minus. Underneath here, that is a negative 8 times a 4, negative 32. 9 minus 32 is negative 23. It's all over 4. This is what we just had before. X equals, what am I doing here? Just to make it look like the one before, that's a common denominator. That 4 is common for both terms upstairs. So just to make it look more like the one before, I get 3 over 4, and then I get negative 20, the square root of negative 23. Don't forget, the negative under there is an I, so that's a square root of 23I over 4. And that is what we just got before. All right, now, depending on who you are, you might find the quadratic formula easier, you might find the completing the square easier. But either way, there are going to be times where completing the square is much more preferred. And it determines when we're starting to analyze functions and looking at their graphs and figuring out what's happening. So think about transformations. Okay. Now before, this same problem when we were completing the square, we were at this point. We had, let me see, we had this. We had, oops, hold on. Let me make that groove. There we go. Here, I'm going to work in here. We had x minus 3 over 4 squared. And that equaled, we'll just call it what we had over there. We had square root of 23 over 4i. Don't forget, plus or minus. Okay, so if I move that term over, we're going to be left with this. I have x minus 3 over 4 squared plus or minus radical 23 over 4i equals 0. And right here, I'm not going to say it, but start thinking about what I mean. Transformations, all right, based on the parent graph, y equals x squared. Can you tell me what's happening here? We'll talk more about that in class. Do you remember what this is called? Just the value underneath the radical symbol? Huh? That is called the discriminant. And that will help us figure out what type of roots we have. Okay, let's talk about them. All right, now the discriminant, which was b squared minus 4ac, will tell us what type of roots we have, the nature of the roots. There are 3 scenarios for this value under the radical symbol. This value is either going to be a positive value, it's greater than 0, or it's going to equal 0, or it will be a negative number, it'll equal 0, be less than 0. If it is a positive number, if it's greater than 0, that tells us that we have 2 different real roots. Not only are they real, but they're not the same. They're 2 unique, distinct roots. Okay. What if it's 0? Well, that tells us that we have 2 of the same roots. 2 of the same roots we call a double root. Okay. Like we have, say we have x equals 3 and x equals 3. Well, there's a double root because that came from the factor x minus 3 and x minus 3, which is the same as this. Okay, so there are going to be times where you get a double root. What if it's negative? If that value is negative, well then think about it. That's going to give us a negative under the radical symbol, and that is 2 imaginary roots. Okay? Now, I like to just think about it this way. Let me just make this a little bit smaller. Okay. So we got this quadratic formula right here, right? Now, this value under the radical symbol, it's either going to be positive, or it's going to be 0, or it's going to be negative. Well, if we're doing this work and we get x equals whatever this negative b is, plus or minus this positive number here, all over some other number, 2a, well, that means that we have x equals negative b plus some number, positive number, over a number, 2a. And we have x equals negative b minus that positive number over 2a. Well, that, when you add and subtract the same number from a different number, you get two different numbers. You get two different real roots. All right, well, what if that value is 0? Okay, so if it's 0, that means I have x equals negative b plus or minus 0 over 2a, which means I have x equals negative b plus 0 over 2a, and I have, let me do it over here, x equals negative b minus 0 over 2a. Well, if I'm adding and subtracting 0, that doesn't change my number. I have negative b over 2a and negative b over 2a. All right, what if that value is negative? Well, I think we just talked about that one. If you have negative, then you're going to have x equals negative b plus or minus. A negative under there means we have a negative, an imaginary number. And when you add the imaginary and subtract the imaginary, you get two different imaginary roots. So when we're solving for these imaginary numbers, they always come in the same fashion. They always come like this. Say we get some real number plus or minus some imaginary piece. They always come in pairs like that. We have 2 plus 3i and 2 minus 3i. What do we call those? You may remember those are called conjugates. Conjugates. Okay? Oh, that's an O. Conjugates. Now for the moment you've been waiting for. What are we going to be working on in class? Well, hopefully you took good notes, and this will be fairly easy. We are going to work on page 192 and 193. See you then.